All right, here we go. Let's take a look at the next section here. We're going to talk about inverse trig functions, which are pretty awesome. We've actually done this before, but we're going to go way more in depth. So I want to kind of do a quick review to get us started here. So I know you can do this first problem. This is old school geometry, but let's just humor me for a second. Let's review this real quick. So when I'm talking about a trig function, I'm saying, hey, what trig function relates this angle to these two sides? Is it sine, cosine, or tangent? Sure, it's the sine. We're talking about opposite over hypotenuse. So we would set these bad boys up so we could find the missing side of the right triangle. We were all happy. Everybody loved it. But let's make sure we really know what that means. What in the world is sine of 42? Well, the sine of 42 is just the ratio of the opposite side over the hypotenuse. So it's just that fraction. So it could be any size triangle. It could be this little baby right triangle with 42 degrees. It could be a huge one. There's a big 42-degree angle with a right angle, but it's that ratio of A over B, or opposite over hypotenuse. So any triangle, they're all similar. As long as they get that 42-degree angle, they all make that same ratio. And then a lot of times we can type, ooh, I already did that, sneak peek there. But we can already type it in there. This will give us that ratio. It tells us the ratio is 0.66913. So that's what the sine of 42 is. It's just telling you what that fraction is equal to. So normally we kind of didn't really show that step. We just, when we were solving the equation, we just kind of said, hey, I'm just going to times by 9 just to solve this bad boy, and we kind of did one step. But really we're saying, hey, the sine is like 0.6691 blah, 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 equals the ratio of the opposite side over the hypotenuse. So anytime I want the decimal or the fraction, I just put in the calculator, I took the sine of 42. And then we can solve and find that side. Awesome. So what is the opposite of that? Well, the opposite would be, what if I don't know the angle, but I know the two sides of the ratio? So now it's still sine, but I don't know what sine is. I'm saying, hey, it's the sine of some angle. It makes 3 over 8. So now I know that decimal. 3/8 is just 0.375. So there's that ratio that we're talking about. And we're saying, hey, what angle creates that? So in this case, instead of putting the calculator, we didn't just say the sine of, we don't know the angle. So anytime we don't know the angle, we would do what? We would do this inverse sine, second sine. So above it in blue, it says inverse sine. And we would type in that ratio, or in this case, I'm just going to put that little decimal in there. Boom, 22 degrees. So what is the actual step here? So what are you really doing? You're actually taking this inverse sine of both sides. You're going to say, hey, I'm going to take the inverse sine of this. Ooh, can I slide this bad boy over here? Okay, I slid that over just why, so I can sneak this in. I actually took the inverse sine of both sides. So you're taking the inverse sine of the ratio, and then boom, what happens here? The inverse sine cancels out the sine. Just like think about if you have an x squared and you want to get rid of it, what do? You square root it. They're inverses each other. They cancel each other out. That's exactly what we did here. And I think I said that was somewhere around a 22-degree angle like that. So that's what inverse sine is when you have the decimal or the ratio and you want to go back to the angle, versus when I have the angle and I want to solve part of the missing ratio. Awesome, great. All right, so let's go ahead and start to try to graph these inverse trig functions. So to do that, let's come over here and start with a regular trig function. So sine of x, we're pretty good at. I got a graph down here for you. Let's just talk real quick domain and range. No problems with x's. You can put everything in there. We're going to say it's all real numbers, or I'm going to use the fancy R for all reals. Super cool. This goes forever and ever and ever. How about the range of this bad boy? So it's limited, right? The lowest it ever gets is -1. The highest it ever gets is +1. So we say, yeah, we got this. The y's are all sandwiched between -1 and 1. Great. So why do I have the graph? Because I want to get to the inverse graph. So when I think about inverses, what do I think? I'm always thinking, hey, I'm just switching my x's and y values. They're inverses of each other, so I'm going to switch x and y. So when I do that graphically, what's going to happen? Well, maybe you already noticed. Check out my x-axis. Oh, it's the y-axis now. And check out my y-axis, the x-axis. They switch. Just like your range becomes your domain and your domain becomes your range. They switch x and y, inputs and outputs. So what's that going to look like? Well, imagine this graph. We can do a couple points here. I'll do 0, 0. I love that point. Switch 0, 0, you're still 0, 0. How about this point? This point is over pi over 2, up 1. I'm going to switch that. So I'm going to go, what? Over 1, up pi over 2. So see how the values switch? This is over 1, up pi over 2. And then we can kind of plug and chug the rest of the points here. As I get it over here, it's going to come over here. Get down here to -1. -1 is going to make 3 halves. And then 2 pi is at 0, or 0 is at 2 pi. So do you see this sine curve whoosh, kind of coming through like, oh my goodness. Okay, so let's see the sine curve coming up, down. I guess it's left and right. It's no longer up and down, it's left and right. And then the same thing, if you want to keep the pattern going the negative direction, I've got this going on forever curve like this. So, is that a function? No way that's a function. Does not pass the vertical line test. This doesn't pass the horizontal line test. It's not invertible. We can't invert this. So you could go ahead and say, yes, if we could do it, we could get the domain and range here. We would just flip-flop them. But because that's not really a function, we limit it to what we call the principal value. So what we're really going to do is we're going to limit the area we're looking. So let's go back to this graph. We're actually going to take just part of this graph, and I'm going to highlight it. I love the highlighter. What part do we want? Well, to make it past the horizontal line test, or to make it invertible, we are going to go from negative pi over 2 to pi over 2. So we all just kind of agreed. This is the area. There's a bunch of areas we can look at, but this is the one we're going to take from negative pi over 2 to pi over 2. So what we're going to do is we're going to say, hey, I don't want all reals. I'm going to say, let's go from negative pi over 2. Actually, let me use x. We're going to say from negative pi over 2, and x is sandwiched in between there, to pi over 2. So we're going to limit where these come from. So we're going to restrict the domain of the function so that we can invert it. Well, what's that going to do over here? That's now going to be the range, and we call these the principal values. So we all can agree which ones we're talking about. We know what part of the inverted function we're going to be at. And what is the domain? The domain is still, and this becomes, oh, not x anymore. If I switched it, what's this become? The y's. Excellent. Now, the range will still become the domain, so I'm going to say the domain is still sandwiched between negative 1 and 1. Awesome. So what's going to happen here? Let's graph this bad boy. So if I'm only talking about this little piece right here, that's all I'm talking about. That's all that's going to show up over here. So let's start at negative pi over 2, negative 1. So that's going to flip to, I'll write this down. This is too much here. So I went over negative pi over 2, is this first point, and then I went down 1, is that point right there. So on my graph, what's going to happen, I'm going to alternate it. I'm going to say, hey, negative 1 makes negative pi over 2, and I'm going to go down to right here. 0, 0, super easy. I love that one. It looks like this. And 1 makes pi over 2, just like 1 pi over 2 makes 1 over here. So what's going to happen here? I've kind of got this little squiggly curly guy right here. So when we use the restricted domain, this is actually what it's going to look like over here. That's going to be our restricted values for that. So when I do that, it kind of relates back to the unit circle, and we're going to do this more here in a second. Well, what part of the unit circle is that? We're talking about, and I love my highlighter, we're talking about from negative pi over 2 to pi over 2. So remember this in the unit circle. This is 0 to pi over 2. This is 0 to negative pi over 2. It's these two quadrants. So we're always, when we're talking about the main values, the principal values, we're always with sine going to refer to quadrants 1 and quadrants 4. So going back to that unit circle, I love the unit circle. I hope you do too. It's so fun. So the restricted values are going to be this part of the unit circle, because if we keep going around and around forever and ever, we get this periodic motion. It goes forever and ever. So we got to restrict it down to this. Awesome. What if you just want to double check it? You can. We can check the calculator out, and it'll show us to make sure we're not crazy here. Just plug it in there. So I want to say, hey, I'm really interested. What is the inverse sine of x? Just be careful. When we're doing this, we're always going to be in radians. So check your mode. I happen to be in degrees. Make sure you're in radians. Change that calculator over. And then anytime you're doing trig, just zoom 7, zoom trig. It gives you a nice window. And you can see it's just that little squiggly line. Now, really, that would like to go on and up and down forever and ever, just like our picture over here, but we're restricting it to that. Dude, that's awesome. Let's do 2 more of these bad boys. What about cosine? So we're going to restrict the cosine. I could graph this forever and ever and ever, but I don't want to do it. Let's start with that, and then I'm going to erase it. So you may want to do this lightly. So I can see this starts at 0, 1. So I'm going to start at 1, 0. So it's a good practice to invert these points. This is pi over 2, 0. So I'm going to go 0 pi over 2. And then this is what? Pi and negative 1. So I'm going to go negative 1 and pi. And then once you see that, you can probably see the pattern. It's just like you're finding your points in the opposite direction. You're going up and down instead of left and right. And then we've got this nice curvy curve going on here. There it is. We're going to take a break. All right, keep it going again. Awesome. But not a function. So what happens here? Well, it don't make it easy for you. We got to go ahead and restrict the domain again. But this time we're going to say we're going to use this chunk right here. So we're going to go from 0 to pi. That's going to be our restricted domain. So it kind of changes things here. So we are actually going from 0 to pi. Excellent. And so I got to trim up my graph here. So I want to erase what? This is the domain, so the range can only go 0 to pi. So I'm going to stop here at pi. That's good. I didn't like that part of the graph anyway. Get rid of that. That was all squiggly. Well, that looks pretty good. And there's my little guy right there, chilling. He's good to go. So we're going to restrict this domain if we're thinking about the old, I thought I had a unit circle. There it is, the old unit circle. What quadrants am I talking about here? From 0 to pi is actually these first two quadrants. So when I go to restrict the domain now, and this is going to be important coming up here, we are talking about quadrants 1 and 2 is my restricted domain. And then that's what's going to show up on my inverse cosine. Check this out. I put arc cosine, same thing. So that is the exact same thing. Sorry if you're like, what is he talking about? It has to do with the arc length of the unit circle, actually. So that's why that is there. So we're going to say, hey, it's the same thing if I want to find the inverse cosine like this, cosine -1 of x, or you can say arc cosine. So we're going to use them interchangeably. Be cool with both. So same thing here. This is just inverse tangent. So don't freak out. Probably should have led with that. Inverse tan is tan -1. Awesome. Or arctan. Fantastic. Let's restrict one more domain here. So I graph tangent for us. We could graph up all these. They're basically going to be these same things sideways. We could go forever and ever, ever. Let's just go ahead and restrict it first so we know what we're talking about. Luckily, this one is a repeat. We pick this one right here on 0. It's the only one we're going to use because it passes the horizontal line test. It allows us to go ahead and invert it, which is fantastic. So which one is that one again? That is from where? That's back to -pi/2 and to pi/2. Now notice it is undefined on those endpoints. I get that. It is going to be, that's the asymptote. So it's kind of a nice thing for graphing. So I've got this asymptote at pi/2 and pi/2, but instead of being vertical, when I go to graph it, what's going to happen? It's horizontal. Remember, I'm switching my x and y, so we've got these asymptotes at y equals pi/2 and y equals -pi/2. I can see 0, 0s right here. Great point. 0, 0. Now the question is, does it start high and come low, or does it start low and come high? So let's just pick a point here. If I go negative, I can't get to pi/2, but I'm way down here as I get close to pi/2. So this is getting more and more negative. So let's switch it. As I get more and more negative, what am I approaching? I'm approaching -pi/2. So it does start low, and then it goes high. There it is right there. That is the flipped values. Now I don't want to stack them, not a function. So I have the restricted domain. How does that relate? What quadrant is -pi/2 to pi/2? Let's get back to the old handy dandy unit circle. And -pi/2 to pi/2 is these two quadrants. So jot this down, have these. We need to know these restricted domains. We're again talking about 1 and 4. So sine, tangent, they're the same. We restrict them the same. And then have a ballpark idea of these graphs. Awesome. Let's see if we can put it all together, including its graph. This is the big dog right here. I like it. If this makes sense, you're golden. So let's find the inverse function. So how do we find inverse functions of anything? Well, we switch our x and y. So the f of x is the y. We're going to switch x and y. So here was the x as part of the sine. I'm now going to make it y. And then I'm going to solve for y. So we switch x and y, solve for y. So can I solve this equation? Sure, just subtract 1 from both sides. We've got x minus 1 equals 2 sine y. And we've got 2 sine of y right here. I went ahead and put in parentheses. You don't really have to if it's just by itself. How do you solve this bad boy? Whoosh, divide by 2. Divide by 2. So we've got x minus 1 all over 2 equals what? Equals the sine of y. I left myself some room there strategically. Well played, Mr. Brust. Because what am I going to do? How do I get rid of a sine? Well, I can unsign it. I can inverse sine it. So I'm going to inverse sine everything in here. Whoosh, there we go. And then whatever I do to one side, I got to do to the other. So you're going to get some weird looking answers. Don't freak out. It's okay. They just are going to look a little crazy here. So what happens here? Well, inverse sine cancels the sine, and I'm left with what's ever in there, which in this case is just y. And then what happens here? Nothing really exciting. We're just going to leave it alone like that. Okay, there it is right there. So I'm going to go ahead and write it as with the notation because I kind of changed everything over to x and y, which is totally cool. But let's go back to our function notation here. So I'm going to say the inverse function equals. Now this is kind of weird for me to see everything going on as is. So I know it's the inverse, but I've got this idea. So I'm going to take this 1/2 and put it out front. I just want to make sure that's coolio. I don't want to lose you here. Instead of dividing by 2, I'm going to multiply by 1/2. So really, in the parentheses, I'm going to multiply by 1/2 x minus 1. And there's a reason for that. I picked kind of a hard one here for the notes. We're gonna bring the pain here. Let's just do it. So why did I do that? Well, now I can see everything going on. So do we recall what a sine function looks like? Yes, I know it's between negative pi over 2 and it crosses at 0. I remember this. And I'm going to hook you up in the beginning as you get used to this. It did not curve very well. Let's make that a little more curvy. So it's the part of the sine curve, if you have to envision all going on, between negative pi over 2 and pi over 2. Now let's talk about the parts. We got some action going on here. So what does this do? Well, this is a horizontal dilation. Remember, this is going to stretch it horizontally. So I've got this horizontal dilation right here. And remember, it's the opposite of what you would think. So it's going to be horizontal dilation of 2. Boom. So I got to take that into account. What does this bad boy do over here? It's a translation. So I've got this horizontal. It's going to shift it. I'm just going to write shift if that's cool. It's going to shift it right 1. But it's a horizontal translation of 1. So now what happens is you're going to have to take your function and you're going to have to manipulate it. So there's sine. I'm sorry, inverse sine. I need to do a horizontal what do you call that? Stretchy. So I'm going to stretch this out. Let's just change colors so you can see it happening. So it's going to get twice as big. So he was at -1, becomes -2. 0 stays here. This one comes out here like that. So now I've got this stretch like so. So I stretched it out. After we stretch, then we can move. So we're following all our same rules from earlier in the year. And now we're going to move it right 1. So we just move it over right 1. My dots did not want to join it. Let's make sure they come with. That's awkward without them. And I get this. Maybe I need to come right a little bit more. There it is right there. Holy cow. So I stretched it and I shifted it. So in the beginning, I'm going to hook you up with the parent function and let you kind of manipulate it. But it's all the same rules. It's just that one little line and you got to move it around. Dude, that's awesome. All right, now that we have it graphed, let's take a look at the domain and range of the inverse function. So this is pretty cool. We know the domain of the original function. So what's going to happen for the inverse function? Well, it's going to become the range of the inverse function. So that one's pretty chill, man. We just know this domain actually becomes the range of the inverse function. So that one's pretty chill. How about this, though? We got to find the domain of the inverse function. That's our goal. We're finding this inverse function here, domain and range. Well, we already found it. We already graphed it, but I just want to make sure we can list the domain and range. So I know we could look at that graph and figure it out, but every time we're not going to graph it. So let's do it algebraically here. So how am I going to get that domain? No problem. We're just going to plug these endpoints in. So we know that it's invertible on this. That's why I picked this restricted domain. So all I got to do is plug the endpoints in. That's going to be my max and my min. So first let's plug in the left one. So we're going to say -2 sine x. But in this case, we're going to say x is negative pi over 2. Boom. Plus that 1. And then we'll do the same thing. We'll plug pi over 2 in and find it. Let's go ahead and write that out. Then we're going to come over here and find the other endpoint. We're going to say 2 sine of positive pi over 2. And that's going to say plus 1. So that'll give us our max and our min here. So what is the sine of negative pi over 2? Remember, that's just our negative 90. Ooh, that's a rough x and y axis there. But where am I at? I'm down here at what? 0, 1. So, or 0, -1. So I know that the sine of negative pi over 2 is -1. Add that 1 to it. I'm going to say -2 plus 1 is -1. Awesome. Can we do the same thing over here? I'm going to say 2 times the sine of pi over 2. That's this point up here, which is going to be positive 1. and then I'm going to add the 1 to it. So 2 times 1 plus 1 is 3. So that is going to be my new what? Domain. So it was the range of this function. You found the range of the function. So then it'll become the domain of the inverse function. So from -1, x is stuck between -1 and 3. So is that cool? So we just graphed it. Let's pull that picture back up that we just graphed. We just graphed it. Is that our true domain and range? Did we do it correctly? Hopefully so. Yeah. What's the domain from -1 to +3? So there's the domain. And where's the range from -π/2 to π/2? So we're going to do it algebraically. Just plug and chug. Get those numbers. Awesome. Last part of this. Let's change gears. So that's what inverse functions are. Why do we need them? Well, we're going to use them a lot the rest of the chapter. And we're going to solve some equations coming up. So we have to take a look at what's going on here. So if I want to find the inverse sine of 1/2, I like to think about what am I doing? I'm thinking about, hey, what angle can I take the sine of that will give me a ratio of 1/2? So what I like to do is go to my handy dandy unit circle. There it is right there. And what can I do with this? I zoomed it in. We kind of have to have this memorized. We just got to know these different parts. So don't freak out. If you need to use the beginning, that's okay. But then you really got to start to work to the point where you just know what these are. So do you know what sine value makes 1/2? What angle makes 1/2? Well, I can see it right here. Remember, it goes xy is cosine sine. And so I'm looking for, there it is right there. There's the sine, and that is π/6. Is that the only place where it happens? No, it actually happens over here, doesn't it? If this angle is π/6, this angle is also π/6 less than pi, so it's 5π/6. So it happens again. It actually happens twice. But we got the restricted domain between -π/2, which is down here, and +π/2. So when we're talking about inverse sine, there's that highlighter. Woo! We're talking about these two sections right here. That's the only place I can pull them out. So when you do your calculator, it's going to tell you only from its restricted area here. So if I have the restricted area, it's quadrants 1 and 4. So now I know I'm talking about π/6, not 5π/6. So that is called, the answer here, let's just write down so we have it, is π/6. That is called the principal value, the main value, the one that comes from the invertible function. So we know which one, because technically it's infinite. We could go on and on and on and on about that forever and ever and ever. Awesome. Okay, let's try number 2. So we're thinking about inverse cosine. Remember, it's x comma y cosine comma sine. So where do I get a negative? It's got to be the negative. So I see radical 2/2 right there, but I need it to be negative. This is where I'm going to get the negative because the cosine's first. So that's π/4. What's his friend over here? Well, this is going to be what? 3π/4. So if you have a hard time thinking about this, just think about what would make 1 pi. 4π/4 would make 1 pi. I'm π/4 less than that, so I'm 1 less. I'm 3π/4. So there's where it's going to happen. So it's got to be 3π/4 because it has to be the negative. That's the key. And when I'm talking about cosine, I've got a restricted domain. Where is it? Where's my restricted domain? It is in quadrants 1 and 2. So when I think back to that graph, remember I was only graphing in these two quadrants. So the restricted value, the principal value that comes out of that, it's got to be up there. It can't be the positive one. It's got to be the negative one. Woo, that's intense. A lot of unit circle. Hope you like the unit circle. What about tangent? Tangent is tricky. I'm not going to lie. So if you don't have the circle there, you can draw your own unit circle. Don't freak out. You can make your own. Just a rough sketch is cool. Now, tangent is what? Tangent is really sine over cosine. So we're looking for, hey, the tangent is sine over cosine. I need that to turn into radical 3 over 1. So what possible combo does that? Well, that's going to happen when I'm looking for 1/2 radical 3 over 2. Now, why do I know that? Well, I just stack them. So radical 3 over 2, if I stack them, if I say sine over cosine, I know radical 3 over 2 over 1/2 has the same denominator there, right? So they're both 2, so they cancel, and I'm left with radical 3. So in this case, when I'm looking for radical 3, I'm looking for the sine value to be radical 3 over 2, the cosine over that. So where does this happen? Where do we get that? That should be up here at what? That's pi over 3. So at pi over 3, And then again, we'd have to be careful because we could have the negative version of that. It actually happens twice, here and here, but remember this is the plus minus. So if you had a negative denominator, you'd have a negative radical 3. That would be a bummer. Not so much a bummer as that would be a different problem, a different answer. So I have to look in the restricted area. Again, tangent's going to look in 1 and 4. In this area, I have to find the right sign of it. It's the positive version. So that's why I'm up here in the first quadrant, not the fourth quadrant. So there's choices. Don't pick the wrong one. You have to think about it, take your time to come up with these answers. That was intense. We need practice on that. That'll get easier and easier the more and more and more you do. Awesome. All right, that's it. We just knocked out inverse trig functions. That was pretty awesome. Good luck on the practice and the master check. Peace out.